So exercise 1.2, state whether the following statements are true or false. Justify your answer. The first question, every irrational number is a real number. So yes, true ma. True, because the set of because the set of real numbers
The color of my blood.
set of real numbers consist of rational and irrational number. Rational number and irrational number. Irrational number. Irrational number. Okay. So real number is a combination of rational and irrational. Real number is a definition. Real number is a combination of rational and irrational. So every irrational number is a real number. The second question, every point on the number line every point on the number line in the form root m, where m is a natural number. M is a natural number. So every point on the number line in the form of root m, where m is a natural number. So not possible ma. False. For example, I have explained one example. Square root of 2 by 3. Square root of 2 by 3 is a real number. Is a real number. On the number line. But 2 by 3 is not a natural number. So every point on the number line is from root m, where m is natural number, not possible ma. Are you understood in the question ma? Square root of any number kuda natural number avutundi ante not possible. Okay, not possible. Next question number 2. Honest, write down ma. Okay. Every real number is an irrational number. False. For example, 1 by 2 will take is a rational number. Is a rational number and hence it is real. But it is not an irrational number. Okay. So every real number is combination of rational and irrational, but every real number is a rational, irrational, not possible. So 1 by 2 is a rational and irrational, but it is not 1 by 2 is a real and rational number. 1 by 2 is a 1 by 2 అనేది రేషనల్ అవుతుంది, రియల్ అవుతుంది. రేషనల్ రియల్ రెండు అవుతుంది, బట్ ఇర్రేషనల్ అవ్వదు. సో కనుక ఫాల్స్. ఎవ్రీ irrational number is real number is a combination of rational and irrational. Okay, write down. So write the question. Are the square roots of all positive integers irrational if not give an example give an example of the square root of the square root of the square root of a number that that of a number that is a rational number is a rational number. Okay. Are the square roots of all positive integer irrational? Emma, yes or no? No. So square roots of all positive integer irrational, not possible. Root 4 is 2. 2 is a rational. 2 is right as 2 by 1. P by Q form. Okay. So perfect squares are not irrational numbers. Okay. Answer no. No. The square roots of all positive integers irrational. If not give an example of the square root of number that is a rational number. So what is the example now, ma? Which one you will take the example? Root 4 example. So root 4 is equal to, or root 9 is equal 3. So 2 is a rational number. Simply 2 is a rational number. Two is a rational number. That is 2 is right as 2 by 1. P by Q form. So very important. So how root 5 can be represented on the number line. Okay, first you have to draw the right angle triangle. First we draw the right angle triangle. So I will take OAB. OB is hypotenuse. I will take hypotenuse OB or AC, no problem. Okay, OA, I will take OA side 2 centimeter or 2 units, 1 unit. So 2 units. Consider triangle. Consider triangle OAB. Okay, consider by is a right angle triangle. Right angled triangle. Triangle at A. At A. By Pythagoras theorem. So what is the Pythagoras theorem? Square of hypotenuse equal to sum of square of other two sides. Square of hypotenuse OB square equal to AB square plus OA square. So that is the value 2 square plus 1 square. Okay, AB value is 1. 1 square plus 2 square. 1 plus 4, that is the value 5. OB square. OB is equal to square root 5. Okay, next draw the number line. Next we have to draw number line. So I will draw number line. So 0, taking negative numbers. Next 1, 2, 3, 4. So first you take 2 units. So 0 to distance 2 units. Next draw the perpendicular 1 unit and join OB. And join OB. So 2 units and 1 unit, that is the root 5. So taking radius OB. Taking radius OB, join. Okay. 2.36 and join the square to the discussion. Square. Sorry, rectangle. Rectangle form. This is the OABC is a rectangle. So draw OABC rectangle. Okay. OABC is rectangle. OABC is rectangle. So on the number line, on the number line, on the number line, take 2 units, take 2 units, take 2 units from O, and represent the point as A. Draw the perpendicular. Draw the perpendicular. Draw perpendicular and mark B. And mark B such that AB is equal to 1 unit with O as center. O as center and OB as radius. Draw an arc. Draw an arc Draw an arc to cut the number line. To cut the number line. To cut the number line at C. Now C represent. Now C represent root 5. That is right. So terminating decimal. If any number is divisible by another number, the remainder becomes 0. The remainder becomes 0. If the remainder is 0, then it is a terminating decimal. Next, non-terminating decimal. Non-terminating decimal. Non-terminating decimal. The remainder never becomes 0. The remainder never becomes 0. Remainder is not 0, then it is called non-terminating decimal. So example 5. So same definition 10th class lo kuda untai. So P by Q is a number. Denominator is form of 2 power n into 5 power n. It is multiple by 2 or multiple by 5 or 2 and 5 is multiple, then terminating decimal. So direct answer cheppayachma. Denominator 2 to or 5 to 2 or 5 any number it is divisible by denominator number, then it is called terminating, otherwise non-terminating decimal. For example 3 by 4, the denominator is divisible by 2 or 5, so it is a terminating decimal. So in 9th class, how to follow the taking 0, 4 7 ja 28, remainder is 2, taking 0, 4 5 ja 20. So after 0.2 decimal, so 3 by 4 is equal 0.75. Remainder is 0, then it is called terminating decimal, and decimal expansion of 3 by 4 is 0.75. Okay, next, otherwise 7 by 3. So 3 is not divisible by 2 or 5. 2 to 5 to divisible kaadu. So 7. 3 2 ja 6, remainder is 1, taking 0. 3 3 ja 9, remainder is 1,
Like
taking
3
0.
by 4 terminating decimal ki value example
Yeah, terminating decimal. So next reminder 3. The process is continue. 7 by 3. The process is continue. 333. 2.333 is right as 2.3. So it is a non-terminating repeating decimal. It is non-terminating and also repeating decimal. Non-terminating repeating decimal. Right down. Okay. Decimal expansion is find out now. So first we have take నేను 1 చేస్తాను. 1 by 7 చేస్తాను చూడండి. 7th 7 0.7 1 ja 7, remainder is 3. 7 4 ja 28, remainder is 2, taking 0. 7 2 ja 14, remainder is 6, taking 0. 7 8 ja 56, remainder is 4. 7 4 ja 7 5 ja 35, remainder is 5. 7 7 ja 49, remainder is 1. So 1 is repeated. So and so on. Only repeat అవుతుంది. So decimal expansion of decimal expansion of 1/7 is equal 0.142857. రిపీట్ అవుతుంది మళ్ళీ. సో సింపుల్ గా 0.142857 బార్. ఓకే, ఇలా చేయాలి. రైట్. సో రిమైనింగ్ డూ హోంవర్క్.